Hello and welcome to the Car Care Nut channel. In today's video, I'm going to continue my series on how Toyota engine controls work. In today's video, we're going to be focusing on the fuel systems, from fuel pumps to fuel injectors to how everything works, and some diagnosis and DIY tips. But before we get started, if you're new to the channel, welcome. Consider subscribing to the channel. Catch up on this series, the first part and the second part, and check out some of my other videos. If you're a returning subscriber, thank you so much for watching another one of my videos. And without further ado, let's dig right into it. So let's talk about fuel pumps or fuel delivery, if you would. So the fuel pump sits in the fuel tank. It's a 12-volt pump, nothing really special about it. You start the car, the pump comes on, it starts pumping fuel to the front. However, I'd like to say one thing. Toyota fuel pumps do not prime. So when you turn the key on, unlike some GMs and some other manufacturers, they don't come on for a few seconds and shut off. I thought I'd let you know this at the beginning. So there are mainly two kinds of fuel system deliveries in Toyotas. There is something called return and returnless. Returnless is going to be your most common one. Your return system is going to be only on trucks, 4Runners, Tacomas, Tundras, Sequoias as well, and Land Cruiser. Let's talk about the return system. The return system is very simple. There's two fuel lines. One goes from the fuel pump all the way to the front and then goes to the fuel rail where all the injectors are. There's a fuel pressure regulator. It regulates the pressure because obviously you're going to need less pressure when the engine is low RPM, potentially higher pressure as the RPMs go up. So there's a little regulator. It is vacuum controlled. There's more vacuum at idle, so that's going to bring the pressure down. It's going to basically let more fuel return back to the tank, lowering the pressure. As you go in higher RPM, there's lesser vacuum. That fuel pressure regulator is going to close, and the fuel will stay more pressurized in the rail. Very simple system, been around forever, really doesn't have that many problems. The second system is the returnless. So the returnless system only has one fuel line that goes from the fuel tank all the way to the injector rail. And by the way, here's how the injector rail looks like, just so you can visualize this. So the returnless system also has a fuel pressure regulator. It's actually built into the fuel pump assembly, like the whole housing. It regulates the pressure when it sees there's a lot of resistance. That means the pressure needs to lower. It's gonna open and kind of dump the fuel back in the fuel tank before it even leaves. They did this for evaporative emissions, for basically cost. You don't have to run two fuel lines to the front, just one fuel line is good enough. So it's a really good system. It doesn't have a lot of problems, and there's not much diagnosis-wise. If you drive Toyotas, they don't really have fuel pump problems. Yes, there is the recall that a lot of people are afraid of. Is Toyota joining everybody else and failing fuel pumps? That's not the case. That recall is just a failed part from the beginning, from manufacturing. You replace it and life is good. But diagnosis-wise, these systems are very simple. I mean, very simple. There is a fuel filter built into the bottom of the fuel pump assembly. It's not really serviceable. You're not really going to do much fuel pump-wise with Toyotas. So the fuel injection itself, let's talk about that for a bit. Let's talk about the port injectors, the regular good old injectors, not the direct injectors. By the way, most people call them GDI. That's not really a Toyota term, it's just direct fuel injection, or actually D4S in most of the Toyotas that have direct injections. Some of the Lexuses, they'll just call it, the ones that have only direct injection, they'll just call it direct injected system. So here is a injector. This is a port injector. Let's focus on these guys now. It's a very simple. Fuel comes through here, and there's a little plunger inside that closes this passage. And this is the side that sprays fuel inside. Now, this is going to spray inside the intake at the back of the intake valve. So it just has a connector. That connector has two wires, a power and a ground. This power and ground just opens a plunger, lets fuel through. So the fuel rail will have pressure. So the pressure is always sitting here ready to be sprayed, but this is closed. When you energize it, you give power and ground to it, it's going to open and it's going to spray. Well, here's how the computer controls this. And this and all the injectors are controlled the same way. All the injectors in all Toyota models, they always have 12 volts all the time. As soon as you turn the key, start the car, they have 12 volts available to them. The ground side is where it controls these injectors. Every injector, the ground side, will go directly to the computer and it has a driver. Remember, we talked about stoichiometric. We said that it needs to maintain that 14.7 to 1. Well, the way it's going to do that is by varying how much fuel we're adding. Remember, we talked in the previous video about it's going to measure the air, it's going to add an amount depending on how much air it's taking of fuel to keep that ratio correct. So the way it's going to do that is it's going to open this injector just for a small, it's like a pulse, and close it. It's just going to pulse that ground. It's going to give it ground, spray, cut. That is called injection duration. And that's counted in milliseconds, not even a second. If you open this injector for a whole second, you're going to flood that cylinder. So it's all measured in milliseconds. The more milliseconds you have, the more this injector will open and the more fuel it will spray. The lesser the duration or less milliseconds is going to open, is going to spray less fuel. So in a diagnosis standpoint, really you're not going to do much with the duration because there is something called fuel trim, which we will cover in an upcoming video in this series that actually calculates, because when you look at the milliseconds, they're just bouncing all over the place. They're changing rapidly, and really you're not going to use that for diagnosis purposes. I just want you to understand how these are powered and how the computer is controlling them. It always has power. It's going to pulse that ground as much as is needed, and it's going to pulse individual grounds as it needs to spray fuel in individual cylinders. So the computer has control of each single fuel injector for each cylinder. Let's talk about some service tips for the port injectors. Now, each injector will have an O-ring here at the top, right there. And then it'll have a big seal or washer at the bottom, just like so. Now this seals the intake manifold. So when this sits, actually it sits on the cylinder head, most of them. This seals, remember we talked about metered air in the previous video? This actually seals it. So if this seal goes bad, you're potentially going to have a small fuel leak, but you're going to more have a vacuum leak because now you're allowing air through this into the engine, unmetered air. When you have a leak from this O-ring, the top one where it goes into the fuel rail, then you're going to leak fuel continuously, regardless if this injector is spraying or not spraying. Now, here are a few service tips. Every time you take this injector out, you're going to replace the O-ring, you're going to replace the bottom seal. Now, some of these will have 2 O-rings. Depends on the model, but you're always going to replace these no matter what. And here's another tip for you. When you install it in the rail, let's say you have a misfire, simple misfire diagnosis. You check the ignition system, it's all good. You suspect you have a bad injector. You're going to swap injectors. Like let's say you have a misfire number 2. You're going to take injector number 2, put it in number 3, and bring number 3 back to 2. And then if the misfire moves, you have a bad injector. Very simple mechanical logical diagnosis method. But here's the thing, when you ever install these or remove them, when you install your rail and you put everything back, before you clip your connector on, you're going to grab this injector. Now this side is going to be on the cylinder head, the rail will sit on it. You're going to grab the injector and you're going to spin it. If it spins freely, it's good. If it's binding and it's locked up, likely this O-ring got cut, this got caught or crooked and it's not sitting right. Before you put your connector though, because usually on some of these, on Toyotas, when you put the injector connector, it locks the injector from spinning. But before you put the connector, make sure it spins freely not super loose, but it's going to spin with even force, not binding and you can't spin it, or all of a sudden it's hard, then it gets loose, and now it's very loose. Then you broke the O-ring. If they're installed properly, you can easily turn this guy and nothing will happen to this. Just the O-ring will spin and they'll spin here, and that's that. So having said that, let's talk about the most important and the most confusing one, direct injectors. So direct injection, or D4S. Now, this system is completely different from your conventional port system. And I'll tell you some basics first before we dig into it. It runs a very high pressure, and the injector does not spray on the back of the intake valve and then it goes down into the cylinder. It sprays directly inside the combustion chamber, directly on top of the piston. So you're not having these losses of travel, and it precisely put the fuel at even more precise time and the exact location, and it creates more efficiency. So the problem with direct injection is you're not spraying it in a vacuum situation. You remember, the port injector, when it sprays, there's a vacuum pulling. So when you sprays the fuel kind of gets pulled in. But direct injection is spraying inside the cylinder where there's very high compression pressure at all times. So the direct injectors, they need to have such high pressure to spray that fuel in so it could overcome the pressure of the combustion, and it's able to push the fuel in. Not as soon as they open, the combustion pressure just pushes the fuel back in. So they need to operate at this super high pressure. The way the system works, it's very simple. Most Toyotas that have direct injection, they actually don't have a second fuel line. They have one fuel line coming out of the fuel tank from the electric fuel pump in the tank. That comes up, then that line splits into two and goes up. One of them goes to the regular port injectors. We're talking about D4S system. And one of them goes to the high pressure fuel pump. So that's fuel pump number 2. It is a mechanical fuel pump. Looks like this. And all it is, and it's actually, we go back to really old cars where the fuel pumps were driven, the regular fuel, there was no fuel pump in the tank, and it was just a mechanical fuel pump. It's operated by the camshaft. The camshaft just pushes a little plunger up and down, and it pressurizes the fuel. Now, this high pressure fuel pump is also computer controlled. It could vary how much pressure it does, and it could actually turn it off completely. So from there, now the fuel that came at whatever the regular in-tank fuel pump pressure is, let's say 40, 50, 60 psi, is going to take that to 3,000 psi sometimes. That's quite a difference, and that little pump does so much. So that high pressure, you can't send it in a hose or a plastic line or even a regular metal line. It has to be a very strong, high pressure metal line that looks like this. Now that line on the service tip, one thing on the side, every time you remove that line, it needs to be replaced, because trust me, you do not want to have a 3,000 psi fuel leak on a hot engine in a hot summer day. That's a bad day. So folks, DIY mechanics, you're working on your own cars here, but for professional, we both know liability. Imagine that scenario when this car catches on fire. That's on you 100%. Any shop, on you 100%. Not worth it. Repairs are expensive. Lives are priceless. So always replace that line whenever you remove it. Now from that line, things kind of return to normalcy. So from that line goes to a rail. Kind of looks like the regular port injector rail, but it's a lot beefier, a lot heavier because it handles very high pressure. And then from there comes our direct injector. I want you to notice the difference between these two. You notice how this one is plastic? This one doesn't handle high pressure. This one, however, just look at this guy. It's all metal. It's very high quality. It's very big, and it's actually very heavy compared to this guy. This guy is almost nothing. Now, you're gonna notice one thing about Toyota, and this right off the bat. When I show you this, you know this is a Toyota or a high quality injector because it's metal. Believe it or not, and I won't take too much of your time, but I'll tell you this real quick. The Supra aka the BMW, the 2020 Supra and up. It has direct injection only, and the direct injectors that handle 3,000 psi of pressure are made out of plastic. Plastic. Toyota don't do that. It's metal, and it's very high quality. Now, these injectors, let's talk about the injector itself. It has so many seals on it, and it has Teflon seals, because imagine when this guy leaks, is going to make a giant mess. When the port one leaks, and it has only a few seals, leaks, going to make a mess. Imagine when this leaks. So it has an O-ring, then a safety O-ring, then another safety O-ring on both sides, then it has this big ring that compresses and holds it in place, seals it to the hole. It has a lot of seals, and replacing these seals is a nightmare. You need special tools, and usually if you don't have the practice, you put the seal on and it fails and it fails and it leaks, and this takes practice to install these seals right. Now the new one does come with the seals, so life's good, but imagine you're replacing one direct injector. You pull the whole rail, you pulled 4 injectors. You cannot reuse these seals. They're all replaceable. You're going to replace one injector that already has a seal, let's say on a 4-cylinder, the rest, you have to replace the seals. Folks, this takes practice. Unfortunately, I would tell you go practice, but if you're going to be working with these, seriously practice, because this takes a little bit of getting used to how to install this seal, because it's a very hard seal that you got to stretch and put on, and there's a special tool for that. The rest of this injector, though, operates exactly the same as this guy. There's a plunger inside, a much higher quality plunger, of course, handling this high pressure. 2 wires go into this, power all the time, and the computer controls the negative side, pulsing it as it needs. Another thing I will say this, and I should have said this when we talked about port injection. Now, the positive side is always there. It's usually fused. You touch that to ground, you're going to blow some fuses, maybe the car will shut off, but that's about it. But the negative side, if you short that to power, you're going to damage the engine computer. And this is a common one. So there's a driver inside the computer that drives these. As I said, when you short that driver, you're going to burn it out, and that's it. There's no repairing that. So when you're working and wiring around injectors, be very careful when you have exposed wiring like rodent damage. You're doing some repairs, you're adding that aftermarket flashing light outside. Don't use injector wire. I see this. I say this because I see this. You burn that, you fry that injector driver in the ECU, you're going to replace the computer. This is a problem. This is going to get very expensive. So leave the injector wires alone. They're not a good source to get any kind of signal. Let them be. And if you have rodent damage, repair it as soon as possible. These 2 wires touch each other, that driver is gone. And now you need a new computer. So before we wrap up this video, I want to say a few things. Now, you went through this video and you noticed that the fuel injection is very simple, which is true. However, we haven't talked about how the computer decides how much to turn on these things. And that we will get to. But I want you to remember one thing. Whenever you're working on any fuel injector, any fuel system, check and double check and triple check for leaks. Folks, cars catch on fire, number 1, from fuel leaks. Number 2, from oil leaks, which oil contains fuel. That's the number 1 reason. So I want you to be conscious. Whenever you're working on these, you gotta double, triple check your work for leaks. Whatever you're doing, this is very important. Another thing is fuel injection cleaners. Toyota injectors, they don't really get clogged that much. We're gonna talk about diagnosis in an upcoming video of this series, but for now, fuel injection cleaning, they work, but they don't do miracles. They're more of a maintenance than a fix. If you have an injector that is clogged, replace it. There's no point of cleaning it. This is not the 80s. These computer controls, they're very delicate, and they're really not one that you want to be cleaning here when they really get clogged. Now, 2 problems with injectors. They're either going to have a clog or they're going to be leaking. Really, neither of those are common. You're not going to have any 5-year-old Toyota with this problem. You're probably going to see a 20-year-old Toyota maybe with a clogging injector or injector that is weak. By the way, folks, these injectors, you can listen to them. They make a clicking sound. So if you suspect a bad injector, listen to them. Put a screwdriver on them, put your ear on it, listen to them. You're going to hear them clicking. Now, the clicking doesn't tell you if they're working or not. But if you have one that is suspected bad, compare the clicking sound from that one to the one next to it. If the plunger is getting stuck or something is going on with it, you're going to hear a difference. And that'll tell you that you potentially could have an issue with one of these injectors. With the direct ones, they're loud, they're proud, you really can't get to them. I wouldn't use that method on these. Plus, direct injectors, dangerous. Please be careful working with the high pressure on these. You're rarely going to be doing these DIY, but we have had issues where the injector just quits or it leaks. And we have seen a few leak. Now, one thing about direct injectors, you cannot replace just one injector without knowing the following. These injectors have numbers on them. If you're replacing all 4 or all 6, whatever the case, that's fine. But if you're replacing just one, you have to watch the number on the injector. When you go get a new one, the dealership will ask you which number do you want, because these are calibrated and they need to be the same. Otherwise, we have problems. Now, all this is somewhat simple. If you think about it, it is not complicated. It is simple. I'm not trying to make something complicated simple. It is simple. It's just 2 wires, computer. But the complicated part is how the computer determines how much to open these, which will take us to the next video of this series about oxygen sensors and air-fuel ratio sensors, which actually have a direct relation to the duration of the injection. I hope you learned something new. I hope you liked this video. If you did, consider giving it a thumbs up. If you're not a subscriber, consider subscribing to the channel. Until the next part of this series, may the Lord bless you and keep you, and you have a wonderful day.